This presentation was prepared for Transforming Timber Work Package 4 and provides details of the developed digital twin solution as utilised within the Transforming Timber project. This presentation is broken up into 3 stages, the first of which gives a brief overview and working principles behind digital twinning. The second section provides details of the implemented digital twin within the first of the Living Lab case studies, and a quick point at the end is provided on the outcomes of the project thus far and expected outcomes in the future. To give a quick understanding of digital twins, we can think of them as consisting of 3 parts. The first part, a physical entity, as shown on the left of this infographic, is a physical entity. It's a building for our purposes, or it could be a window or a door or a part of a building, anything that is a physical entity in the world. On the right hand side we have the second component, which is the virtual entity. You can think of this as a 3D model or any kind of digital representation of the physical. And then the last component are these links between, as shown in the infographic, by sensors and actuators or switches. So with these 3 elements, we have a digital twin, and this allows us to do some interesting things which will be shown later in this presentation. So to provide a quick bit of context, the first Living Lab case study for Transforming Timber to utilise the digital twin is at Fettes College in Edinburgh. This is a private boarding school, and Ecosystems Technologies recently completed the manufacture and assembly of 6 new day study pods at the college, and these are situated outside an existing accommodation block. Now, the infographic you can see before you is similar to the one from a few pages ago. However, it has a bit more of the working details, and this represents what was actually installed at Fettes College. On the left hand side we have the virtual entity, and this also includes the costing, life cycle analysis, material properties behind the 3D model. These were all generated through the Transforming Timber project, and also through all of the design work that went into the new study pods at Fettes College. On the right hand side we have the outputs of that design, which is the actual physical building itself. We have an operational building, and any operational building has a certain energy consumption associated with it. It has an occupancy schedule, so on and so forth. And then in the center we have the links that are required between the physical and virtual, and this is achieved through the use of sensors which were installed in Fettes College. By working in this way, we are provided several very valuable feedback loops. Now, these are just a simple representation, but there's much more detail behind what goes on here. The operational feedback loop is where the sensors themselves, they collect the data, and that can be used to make sure that heating and cooling schedules are running as efficiently as possible. And then likewise, this data can also help us in design. It can feedback right into all of the documentation that was generated at the beginning of the project. This would help us to optimize the delivery of these homegrown mass timber products over the generations. This slide here just shows some of the sensors that were installed in February of 2022 within the Fettes College pods. These report temperature, humidity and CO2. From reading in the sensors, a communication protocol is required. There's a screenshot here showing the communication gateway, and this allows data to travel from the sensor to a cloud storage platform, which we will see now. And here we can see the data being reported in real time. This is a screenshot. This shows that the data as reported in real time, and we can start to identify trends and patterns within the data. So this is again just showing the data over a 24-hour period for CO2. And again, as we increase the amount of data we have available, we can start to make statistically significant observations on why certain things are happening, and be able to characterize the performance of the room in terms of air quality here. So finally, through working in this way, we are allowing future building performance research to be undertaken on the very valuable data that's being collected. Most importantly, for the Transforming Timber project though, we are providing verification of the homegrown mass timber element performance claims. So this allows us to have a very quantifiable evidence record for all of the work that's gone on in the mass timber project, and it allows us to understand the real-time, real-life performance as opposed to just laboratory testing. Finally, this could also have lead-on implications for further digital twin research and facilities management opportunities for the likes of Fettes College.